Okay, in this lab, work kinetic energy theorem, say if it's a theorem, what we need to do a lab, we are going to see the relationship between work done on an object and the change in its kinetic energy. So it's a relationship between work and kinetic energy. Work done on an object by an external force and change in the kinetic energy of the object. So what is work? Work is a physical quantity related to the force acting on the object and the displacement of the object. The mathematical expression is the magnitude of the force that is acting on the object, or net force if it's more than one, the distance that the object travel, or you could say better, the magnitude of the displacement of the object is supposed to be, and the angle between the displacement vector and the force vector. That's why people say distance, force times distance, cosine of the angle. It's better to say force, the magnitude of the displacement, and the angle between the displacement vector and the force. In this lab, because it's a crate moving in a surface on the ground, the angle is 0 and the equation simplify to the force acting on the object, and in this case is going to be just friction, and the displacement of the object before the object comes to stop. What is changing kinetic energy? In this is final kinetic energy minus initial kinetic energy. And because the final velocity of the crate is 0, the change in kinetic energy is just losing the initial kinetic energy minus 1/2 m initial velocity squared. So losing the initial kinetic energy. So this is the simulation that we are going to use. You apply some force, is not shown in the picture at the time, and then you let it go. You don't push the crate anymore. The only force acting in the crate are normal force and gravity. They cancel each other, and it's friction to the left, the net force. The object eventually comes to stop, and you are going to use a timer, the stopwatch timer. The simulation does not provide a timer or a way to measure the distance to see how long the block is moving before it comes to stop. So what you're going to measure in the lab, the initial velocity, you push the crate and then you let go. The time to stop, how long does it take to stop, and the friction, that is just that red vector that you see on the screen. You are going to set up the friction to the maximum, so you put the friction to lots of friction. You are going to calculate the change in kinetic energy, as I told you, is losing negative the initial kinetic energy. The acceleration of the object, that if the crate is 50 kilos and the friction is 188, negative 188, so the acceleration is negative, I think it's 3.75. Force over mass is the acceleration. The distance, you're going to use the appropriate kinematic equation to this, is initial velocity times 1/2 acceleration times t squared. That's how you're going to calculate the distance. And work is just force 188 times the distance that you're going to calculate. So these are the measurements and calculations. If the blue are the measurements, the red and yellow are the calculations. As you can see, the changing kinetic energy, I call DKE, changing kinetic energy, is really close to the work done by friction, as you see in those yellow columns. This is an indication that they are equal. So work, if you plot the graph, you see that the slope is 1. The y-intercept is not 1, but look at the values in the y-axis. It goes from 0 to 4,000. So positive 99 out of negative 20,000 is not much. So this is an indication that the work done on the object by friction is equal to the loss of kinetic energy. And what is the source of error? Why the y-intercept is that big if this is a simulation? Because you use the timer, you use your fingers and the stopwatch in your cell phone to find the time to stop. And that is the source of error in the simulation, because you are physically doing a measurement on a simulation. That's why the y-intercept, even though it's small in comparison to the y values, is big to be a simulation. But it's not a simulation in the sense that you measure the time to stop. And the conclusion question is, why is the relationship between work and kinetic energy? Is work equals changing kinetic energy? And why is that? In the following video, I will prove that equation just using the appropriate kinematics equation. We can show that it's a theorem. This is a theorem. It's not a physical law. It's kind of a tautology, a redundancy, as you are going to see in the last video in this playlist. So this is the lab. In the following video, I show you how to get the data. The video after getting the data is doing the calculations and graphing. And the last video is the derivation to prove that work is equal to the changing of kinetic energy.